Let's discuss one more topic, what we call as direction cosine, or in short form, we call it as DCs, direction cosines. Now, what exactly we mean by a direction cosine? Very simple. Now, what we have to do is, imagine you have the x and y and z axis, all the three. So, assume that you have three axes like this. This is 0. So, assume that this is x, assume that this is y, assume that this is z. Okay, you have x, y, and z axis. Now, we have a point, some point is here P. P is x, comma y, comma z. Okay. Now, from O origin to the point P, we are going to draw a line. Or you can say you are going to draw a vector. Whatever it is, you can call it whatever you. Generally, we say it's a line. So, that means we are looking at a straight line in space. Correct? Now, whenever we look into a straight line in space, now generally what we were doing, now assume that you have just x and y axis. Okay. Now, if you have just x and y axis like this, and if you had a line, then we were measuring this angle theta. Remember, we used to take the slope of a line, tan theta. Now, what does the tan theta gives you? It gives you the angle, isn't it? It gives you the angle of the line is making with respect to what? With respect to x axis, isn't it? But here, but in 3 dimension, things are going to be a little more different. Because in 2D, if you know the angle and if you know the position, you can pretty much get to know where the line is situated, isn't it? Like suppose if I say the angle made by the line is, let's say, 60 degree. Now you can mentally visualize like, okay, 60-degree line is going to be like this, correct? But in 3 dimension, it's a little bit difficult because we have 3 axes, isn't it? Suppose if I say in 3 dimension, in space, suppose if I tell a line is making an angle of 60 degree with the x-axis. What is the angle with respect to y-axis and z-axis? It won't be 30 and 30, not like in 2D. In 2D, with x-axis if it is 60, and y-axis it will be 30. It has no other option because the angle is 90. But then here, when I say angle with respect to x-axis is 60, with respect to y-axis need not be 60. Okay, with respect to y-axis. With respect to z-axis need not be whatever that angle you're thinking about. It can vary completely. This is where the concept of direction cosines comes into play. Okay. Now, in this case, when we have OP, OP being a straight line from O to P, O is the origin 0, 0, 0. Now, with respect to x-axis, it makes one angle. Let's call it as alpha. Alpha. With respect to y-axis, it makes another angle like this. Let's call it as beta. Then, with respect to z-axis, it makes an angle. Let's call it as gamma. Now, a line makes 3 angles with 3 different coordinate axes. Fair enough? Think of it like this, x, y, and z. Okay? And for this, let's say the line is something like this. Alright? Now, I'll give you an example. Suppose, see, assume that this is 60 degree. Now, with the same 60 degree, I can move like this, I can move like this. 60 degrees still maintained. That means here, with respect to just 60 degree, things can change a lot, isn't it? That's why what we do, we take, so with respect to x-axis is alpha, like this one. This angle is beta, and then this angle is gamma. So we have alpha, beta, gamma. So what we do, we take the x coordinate. That's why what we do is, here, see, this value is x, this value is y, this value is z, right? We take the cos alpha. Why we take cosine itself? Because if this is my vector, this is going to be the x coordinate, or in other words, we can say that this particular, the component what you have is going to be the adjacent component of the vector. And adjacent is always given by what? Cosine. That's why we call this as direction cosine. All right. Now look at this one. So what we do, We take cos alpha. Okay, cos alpha is equal to x divided by r. Okay, next cos beta is equal to y by r. Cos gamma is equal to z divided by r. Fair enough? That point P what we have, this can also be written in another format. Okay, so what we can do is we can write this point P as L into R, next one is M into R, the next one is N into R. So the same point P can also be written this way, where L, M, N are the direction cosines. Fine. So from this, we have one more relation, very important relation, that is L square plus M square plus N square is equal to 1. Now, this relation is used in many cases. Okay, many cases. Why? Because look at this one. X by L, what you have, sorry, X by R, we call this as L. So what is X? LR. Again, this is equal to M, this is equal to N. That's how we get that LR, MR, NR. And that's how you get L square plus M square plus N square is equal to 1. Clear? So this is basically direction cosine. Now, in the next video, we are going to understand few problems and few topics related to the cross product and direction cosines.